Our next speaker is Corine. Corine Ngufor from the Liverpool School. London School. Sorry. From London School of Tropical Medicine and Hygiene. Yeah. Thank you.
Thank you very much. I would be presenting on a study that we performed in Benin to compare the efficacy of insecticide mixture and combination strategies against pyrethroid-resistant malaria vectors in southern Benin. So we know that long-lasting nets and IRS are the most widely implemented malaria vector control tools. They are both reliable and they have contributed significantly to the reductions in malaria that we have seen. And they rely on 12 insecticides from 4 classes of compounds at the moment, the pyrethroids, organophosphates, carbamates, and organochlorines. But then we also see that the impact of these 2 interventions depends on the continuous susceptibility of local vectors to the insecticides that are delivered. So currently we have resistance has become very widespread. We have pyrethroid and DDT resistance on the map, which is on the left, which is widely spread in Africa. And we also have increasing reports of considerable resistance to carbamates and organophosphates. And what is particularly worrisome is that we're beginning to see vector populations that are showing resistance to almost all insecticides. And the problem here is that those vector control programs faced with this challenge will not have any other option or any other insecticide to which they can turn. While we have seen this resistance, the impact of insecticide resistance on malaria has been controversial because there has not been a randomized control trial that has shown its impact. And that is because resistance cannot be randomized to communities and withheld from other communities as to exclude any confounding effects. But then we have seen a lot of studies that have suggested that resistance is a major threat. We have seen reduced efficacy of pyrethroid nets and IRS. We have seen loss of protection, and there is also increasing evidence from the field showing poor performance of pyrethroid interventions. And there was modeling study that showed that if nothing is done about resistance, the gains in malaria control could actually be reversed. So there was an urgent call from the WHO for action to mitigate resistance without necessarily waiting for undeniable proof. And the WHO released in 2012 the Global Plan for Insecticide Resistance Management. And 2 major actions which can be taken out of that plan is to identify new chemical products for IRS with new modes of action. We have heard about one from Luke this morning, which can be effective against resistant malaria vectors, and also to apply insecticide resistance management strategies in vector control programs. So the GIP, that's the Global Plan for Insecticide Resistance Management, proposes these interventions or these major strategies, which are rotations, mosaics, combinations of interventions, and mixtures as strategies for mitigating resistance. And they are mostly, especially the last 2, about presenting 2 or more unrelated insecticides to a vector population at the same time. And the principle behind this is that resistant genotypes, which fail to be killed by one intervention, can be killed by the other intervention if the population is not resistant to both insecticides. And this can lead to improved control and a reduction in resistance and preservation of susceptibility for the compounds being used. It's not a new concept. It has been used in agriculture, and it is the basis of the artemisinin-based combination therapy, which is used to preserve susceptibility to artemisinins in the malaria parasite. So the ways in which it can be applied is by using mixtures for IRS, where unrelated insecticides are co-formulated into a single product, or by using combination long-lasting nets, which are nets treated with 2 insecticides at the same time, either as a mixture or a mosaic. And also by using a combination of interventions, that's using non-pyrethroid IRS together with pyrethroid nets. So, but in 2015, there was this publication assessing the uptake of insecticide resistance management strategies, and it showed that it has been very poor at national levels, mostly due to lack of adequate new tools, and we have some in the pipeline through the IVCC. Also, there's the lack of adequate evidence on the efficacy of these strategies, and also critical deficiencies in human, financial, and infrastructural resources. So to provide some evidence on efficacy, we performed this study in Benin, comparing different IRM strategies with the aim of looking at their potential to provide improved vector control. And we focused on two main insecticides, chlorphenapy, a pyrrole insecticide, and alpha-cypermethrin, which is an existing pyrethroid insecticide. And they are to be deployed in three major ways: as an IRS mixture of chlorphenapy and alpha-cypermethrin, or a long-lasting net treated with a mixture of chlorphenapy and alpha-cypermethrin. And this is known as Interceptor G2, which is a new net that is developed by BSF, and it's under consideration by WHOOPES. And also a combined intervention where chlorphenapy IRS is applied, and at the same time, a long-lasting net treated with alpha-cypermethrin is used. So the study was performed in an experimental herd site in Kove in Benin, which is a large rice-growing field, 160 kilometers from Cotonou. It has a very dense vector population, mostly of the Kulozai, and it is characterized by very high resistance with over 90% KDR gene frequency and high expression of metabolic genes, that's the P450s. And we also found a 200-fold resistance ratio in this vector population compared to the susceptible Kisumu strain in CDC bottle-bow assays. So experimental herds, they actually are a WHOOPES system for investigating the efficacy of indoor vector control tools in semi-field studies. They provide estimates of the transmission control potential through the proportions that are killed, and the personal protection potential through the proportions that are blood-fed. And what happens is humans sleep in the hut in the presence of the treatment. Mosquitoes enter, but they can't exit, and they interact with the human and the treatment, and in the morning they are collected and brought to the lab where they are identified and scored. So we didn't just look at the combination treatments, we had also the single AI treatments, and then we tested them alongside the combinations. So those are the 7 treatments that we had in the experimental herds, and we also had 7 consenting human volunteers sleeping in the herds while the treatments were there, and the trial ran for 54 nights. So as the first stage, during the course of the trial, we had to first confirm the levels of resistance. And this slide shows the levels of mortality that we had in WHO susceptibility bow assays during the course of the trial from mosquitoes that were collected at the herd site. And we found that the mosquitoes were very resistant. Mortality was less than 15% with pyrethroids and DDT, but we have also found full susceptibility to organophosphates and carbamates. So this slide summarizes the results that we had in the experimental herds. The blue bars present the mortality rates, while the red bars present the blood feeding rates. So normally in an experimental trial, what you want is to have mortality rates as high as possible and your blood feeding rates as low as possible. So I have separated it into 2 sections. On the left, the IRS treatments, and on the right, the treatments that involved long-lasting nets. So beginning with the IRS, we have alpha-cypermethrin IRS. We had just about 5% mortality. So we had just about 5% mortality with alpha-cypermethrin IRS, which was the same with what we had with the control. And also with Interceptor 1, which is a net treated only with alpha-cypermethrin, we had just about 25% mortality. So this shows that the high levels of resistance, of pyrethroid resistance in that population is actually compromising the levels of control that we can get in experimental herds. So, and one interesting finding here with mortality is that with a mixture that's alpha-cypermethrin and clofenapine IRS, this one, we had around 40% mortality. But when clofenapine was applied on its own, we had about 60% mortality. So mortality was higher with the single clofenapine than it was when you combined it, when you mixed it with alpha-cypermethrin. Now going to the combination and the mixture net, we found comparable levels of mortality when you combined clofenapine IRS and interceptor 1 with the interceptor G2, which is the mixture net, and we also found comparable levels of blood feeding rates. So this shows that these two options for insecticide resistance management significantly improved the control of the vector population. And in conclusion, we can say that the very low rates of mortality we found here with the pyrethroid IRS and long-lasting nets, which is due to the high resistance, further highlights the need for the effective new modes of actions that can be used to control the vector population. And when we compare interceptor G2, which is the mixture net, to the combination of clofenapine IRS and the pyrethroid net, we find comparable levels of mortality and personal protection. But on the other hand, because interceptor G2 is a single intervention, it's a bed net which are known to be much easier to deploy, it could be a more cost-effective alternative to the combined intervention strategy. So, but we don't want to say that, we have to let go of the combination. No. In areas where you have very high pyrethroid nets or high levels of pyrethroid nets being distributed, you can add clofenapine IRS to improve control, and that's a viable strategy for improving control as well. And this provides both mortality due to the clofenapine component and personal protection due to the pyrethroid component. We find that the low mortality rates with the mixture compared to the IRS, the clofenapine IRS alone, is probably due to the excito-repellent effect of the pyrethroid component in the mixture. Because we didn't have that effect when you had clofenapine alone. So that excito-repellent effect could be reducing the contact that mosquitoes are having with the IRS treatment. And also with the mixture net, we found that the G2 provided higher levels of mortality compared to the mixture as an IRS. And this is probably due to the bait effect of a human sleeping under the net compared to when you have the IRS on the wall treatment. So I want to thank all these people who have contributed to the study from the London School, from CREC in Benin, from BSF, and from IVCC. Thank you very much.